Okay, this is 17 from the problem set. It says you want to obtain a sample to estimate a population proportion. Based on previous evidence, you know the population proportion is approximately 67%. You'd like to be 99% confident that your estimate is within 2.5% of the population proportion. So the formula for this, when you're looking for the sample size for a proportion confidence interval, wait till my pen starts working. Okay. Very nice. Okay. Let's get going here. So we have n equals, that's going to be z of alpha over 2 squared times p hat times q hat all over the margin of error squared. So the first thing we want is z of alpha over 2. Okay. This thing really bother me now. Let's go try this again. So here's my normal curve. I'm looking for the z-score that cuts off the middle 99%. So we want the z value that cuts off 99%. This or this. So we'll find the one to the right. That means there's a 0.5% here and a 0.5% here. So this is 0.5% and this is 0.5%. So when I go to the calculator, I'm going to do the inverse normal and find the z value that cuts off the bottom 99.5%. So I will go to this. I think it's going slowly. There we go. Distributions, inverse normal, 0.995. Mu is 0, sigma is 1. So this z value is 2.5758. So we're going to square that. Get that. We're going to multiply it by p hat, which is 0.67. And by q hat, which is 1 minus p hat, which is going to be 0.33. And then I'm going to take my margin of error, which is 0.025, square that, and divide this by that. So I get 2,347.1 or 2,348. 2,348. Okay, I'm not sure what went wrong, but maybe if you send me your work, you're trying to figure it out. This is question 3 on the quiz. In a survey, 22 people were asked how much they spent on their child's last birthday gift. The results were roughly bell-shaped with a mean of 48, standard deviation of 7. I think I know what you did wrong here. This standard deviation is not the population standard deviation, so this is S, not sigma. So we're going to use a t interval, not a z interval, because we don't know sigma. Stat over to t interval. So we have statistics, boom. X bar is going to be 48. S is going to be 7. Our size of our sample is 22. We want 90%, so 0.90. So it's going to be our point estimate, which is 48, plus or minus the margin of error. So I'll just take the top value, 50.568, and minus the point estimate. So I get 2.568 or 2.57.